Hello there. So today is the last day of the April Leetcoding challenge question, and we have a relatively easy tree traversal question. So the question is check if a string is a valid sequence from root to leaf path in binary tree. So the question is really wrong. So we've been given a binary tree, and we want to consider the paths from root to leaves. And for all those paths, they form a valid sequence. And we want to check whether this input string is one of those valid sequence or not. So that basically summarizes what the description of the question is using the title. So that's why the title is quite long. So let's look at the example. We have a tree. So the valid sequence that we can form by traversal from root to leaf is 0, 1, 0, 1, or 0, 1, 1, 0, or 0, 0, 0. So we just check whether the input is one of those. But if we do this, we're gonna have to traversal through the tree, indefinitely to gather all the passes and store them. That will be efficient. So instead, we're gonna try to use this input string as a guidance to help us traversal through the tree. So we see a 0, that's the root node value. So we are so far so good. Then we say the next value is 1. We look at the children's. Only the left children is the matched out value, so we go with that direction. And then we see the input string sequence is 0 in the next position. Since that we have two children, one is 0, one is 1, the only options we have is to go with the 0, so we turn to left. And what comes after is 1. And for this node here, it only has one child that's 1, so we definitely have to go there. But the story doesn't end. Once we reach the end for the sequence, we have to check whether that node is a leaf node. So a leaf node is just a node with no children. And it's indeed that this node 1 has no children, so we can return true because this is definitely a sequence inside the tree. So that's pretty much it. We're just gonna use this input string as a guidance for help us to traversal through the tree from leaf to the intermediate or possibly leaf nodes. When we find such a path, then we can return true. Otherwise, we'll just return false if all the possible attempts are returns are not successful. So the time complexity for this, in the worst case, is gonna pretty much retry all the passes, and there is just one slightly error that prevents this to be a valid one. In that case, the time complexity is the number of nodes in the tree. Roughly number of nodes in the tree, and the space complexity depends on whether you do BFS or DFS. If it's DFS, it's going to be the depth of the tree, but if you do BFS, that could potentially be the the total number of the nodes in the tree. But if the tree is degraded, the worst case for both traversal strategies is also going to be linear. So that's the analysis. Let's start code. This is a pretty easy question today. So we're gonna have a stack to keep track of the nodes and also the current value that we're looking at for this sequence. So it's a stack of pairs. Two things on the stack. It's a tuple. By using pair, I can use the dot accessor. It makes the code a little bit simpler to read. So it's a tree node and integer combination pair. Let's call it nodes. So I have a toe within this, the tree. And initially, we're gonna push the root node and 0 in there. So if we successfully find a path within this while loop, then we're gonna return true in there. Otherwise, we pretty much tried all the possible tools, ways of traversal navigating through the tree. All the attempts are fruitless. We return false. So for the condition here, it's we first have to pop off a node from the stack. Let's call it P or pair. Let's unpack this pair into actual node and index numbers. And then we just compare the nodes value with the array at the ith location. So if they are not equal, then we can pretty much give up on that pass and try some alternatives. Otherwise, we're gonna try to look into left or right based on the value. Although we can actually just be lazy, just put both of the paths on there and have this to help us to determine whether we follow that path or not. Okay. So let's handle the termination here. So if we have the nodes value to be equal to the array's ith number in there, and it happens that we have exhausted all the values in the array, the thing that we want to check is whether this node is a leaf node. So if the nodes have no childrens, then it just so happen that I is equal to the the end of there. We can actually just return true because we find such a path. You know what? We should actually do this here. So this means that we reach the end of the sequence, and we test whether this node is a root node or not. If it's a root node, we return true. Otherwise, it means that yeah, we did get a match, but that node has some stuff after it, so it's not the end of the sequence. It shouldn't be the end of the sequence there. Otherwise, it means that we still have numbers that we want to try to check on based on the sequence. So that's the place where we append the nodes to the append childrens to the stack. So let me quickly check whether the code looks reasonable or not. So we have a stack which is a pair of two things: node, the reference to the node, and the index for the values that in the array that we should match the node's value to that value. And so we start a DFS search. We pop off a node and index a pair. The thing we do is, if the node value is not equal to the number that we want it to be, then we just ignore that path in the tree altogether, the subtree starting with that node altogether. Otherwise, we check if we matched all the numbers in the sequence, and the node is it just so happen to be leaf node, or we just find one of the paths in the tree that's can form a sequence as the input. Otherwise, it means that we still have numbers in the sequence we need to match. We then go explore the children's. So that looks nice. Okay, not really. Yes, switching between languages is just sometimes missing things here and there. Do I need a semicolon after continue as well? Oh yeah, it makes sense. If I return something, I need to. Okay. What about now? Okay. Submit. It's accepted. Okay, so yeah, so this is a linear time and the space in worst case. In the worst case that we have to examine all the passes in the tree. That actually requires the array to be carefully constructed so that it matches as many as possible passes in the partially match as many as possible passes in the binary tree. So which can be difficult. So if it just the values are perfectly reasonably messed up in the tree, then this will be much faster than brute force all the passes and do a template kind of matching. So that's the question for today, and looking towards for the questions you made. Yeah, so that's it.